Hey, Vivek here. And at a distance of 22.8 billion kilometers from Earth as of May 31, 2021, Voyager 1 is the most distant man-made object from Earth. It is the space probe launched by NASA on September 5, 1977 as part of the Voyager space program to study the outer solar system and interstellar space beyond the Sun heliosphere. Voyager 1 and her twin studied Jupiter, Saturn, Uranus, and Neptune. Among the most interesting findings, Voyager 1 discovered a thin ring around Jupiter and two new Xavier moons. At Saturn, it found 5 new moons and a new ring called the G ring. On Feb 14, 1990, Voyager 1's cameras were pointed backward and captured about 60 images of the Sun and planet, the first portrait of our solar system as seen from the outside. These images were the last of 67,000 images taken by the two Voyager spacecraft. But how does a spacecraft send images to Earth? A Wi-Fi router has a range of 30 to 40 meters. A mobile hotspot generated by our smartphone has a range of only 10 meters. Then how does the spacecraft outside of our solar system send information and picture back to Earth? To solve the problem of receiving and sending information from and to the Earth, spacecraft use the Deep Space Network or the DSN. The NASA Deep Space Network or DSN is an international network of antennas that support interplanetary spacecraft mission and radio and radar astronomy observation for the exploration of the solar system and the universe. The DSN is a collection of big radio antennas in different parts of the world. It consists of 3 deep space communication facilities placed approximately 120 degrees apart around the world, near Canberra in Australia, Madrid in Spain, and Goldstone in California. This strategic placement permits constant observation of spacecraft as the Earth rotates on its own axis. Messages travel through space as radio waves, just like the radio waves that we receive with a car radio. Each spacecraft has a transmitter and a receiver for radio waves, as well as a way of interpreting the information received and acting on it. Centers at each DSN site receive incoming information. Then they send it to the Spaceflight Operation Facility at the Jet Propulsion Laboratory in Pasadena, California. There, the photos and the other data are processed and shared with scientists and the rest of us. Our robotic explorers have a lot to do. Small antennas at the spacecraft can beam weak radio signals back to Earth. The further away a spacecraft is, the larger the antenna you need to detect its signal. The largest antenna at each DSN site is 70 meters in diameter. The most distant object that the DSN communicates with are NASA's two Voyager spacecraft. Their signals to antenna are very weak. In fact, the power that the DSN antennas receive from the Voyager signals is 20 billion times weaker than what is needed to run a digital watch. But the engineers have figured out ways to boost those signals so they can be heard loud and clear. Thanks for watching.